Yes. Yeah, good afternoon all. So before I start, can anyone please confirm whether my voice is clear?
Yes, sir.
Thank you. So myself, I'm Vijay. I hold nearly 15 plus years of experience, which includes nearly 8 plus years of experience in Hadoop Spark environment. So as part of today's demo, just I'll be covering the following topics. What is Apache Spark? Why PySpark? Need for PySpark? Spark, Python, and Scala. So which is mostly used, Python or Scala. PySpark features. Real-time usage of PySpark. And PySpark job market. Okay. So what is PySpark? So evolution of Apache Spark, right? Spark was developed by Meta Zaharia, is the personality who developed or introduced Spark in AMP lab, Berkeley in the year 2009. So it was open sourced. It was open sourced in the year 2010, Apache Spark, right? It was donated to Apache Software Foundation in the year 2013. So I define what is Apache Spark. I define Spark in 4 lines. It's a distributed execution framework. It's a distributed execution framework in parallel process style with in-memory computation. Means in-memory computation, like storage and processing, both happening within the memory level, storing within the memory and processing within the memory, in-memory computation, used for large scale data processing. Used for large scale data processing, right? Yes. Okay. Distributed execution framework in parallel process style with in-memory computation, right? Used for large scale data processing. Yes. Yes. Spark used for data analysis, processing, and computations. You see, like why PySpark? So it's a Python API to use Spark, right? It is a Python API to use Spark. So I can say it's a open source. It's an open source cluster computing system which is used for big data solution, right? Yes. So I can say like PySpark is a fast, it's a lightning fast technology that is designed for fast computation, right? For fast processing. So it is a very demanding tool, if we can say, among the data engineers to work with bigger data sets. So it's used for, where we can use this PySpark, right? It is used for distributed SQL, creating data pipelines, ingesting data into database and ML algorithm, machine learning algorithms, and graphs and data streams. We see this need for PySpark. What is the need for PySpark? For performing different types of operations on huge data set, right? So if you see, if you see that, what is the necessity of PySpark? See, if you see, huge data is getting generated through online and through offline, right? So this data as contains a lot of patterns, unknown corrections, market trends, customer preferences, and other useful business information, right? So to extract, it is necessary to extract the useful insights, valuable information from the raw data, right? So we require more efficient tools to perform different types of operations on the bigger data sets. So there are many tools available to perform, right, tasks on this huge data set, but they are not so appealing. So it is needed to use some scalable and flexible tools to crack the big data and gain benefits from that. So PySpark is such a kind. So it's very flexible and provides fast computations. So the combination of Python. So the combination of Python and Spark would be the very efficient for the world of big data, right? So that's why Apache software community, it came up with a tool called PySpark, that is Python API for Apache Spark. So both PySpark means like a Spark is an execution model implemented by using a programming language Python. Combinedly, we call it like a PySpark. So most of the people, most of you will be having seen not only like Spark implementing with Python, Spark can be implemented with other languages like Scala, Java, right? Other languages. Okay. So which can be mostly preferred and what are the differences between? So Spark can be coded with Scala, Python, Java, and R language. So if you see that the difference between Python and Scala, right? Python is dynamic typed, means Scala is static typed. Means what value you are assigning to this X, based on the value assigned, the variable gets created. If you're assigning a float value, float variable created. If you're assigning a list variable created. If you're assigning an integer variable created. Based upon what value you are assigning, based on that, the variable gets created dynamically, right? Yes. PySpark features, PySpark features, right? Lazy evolution. See here, if I see the difference, yes, I was discussing about the Python and Scala. Scala has got a small community. PySpark has got a very large community, right? It has got nearly 89,300 modules for various domains. Python has got various modules for various domains, for networking, for testing, for data science, for big data, for embedded applications, for animation applications, for gaming applications, right? It has got thousands of modules available for provide different environments. But if you see, Scala is only used for Spark. No environment we use Scala, right? So here Python has powerful libraries for ML, machine learning and graph algorithms. Scala has got less as compared with Python. This is PySpark features. What features we see in PySpark? Lazy evaluated. Lazy evaluated means the data flow. If you perform any action on the data flow, only it executes. Otherwise, it won't execute. Generally, any program code, if you just execute, it will be executed right from top to bottom. But just like functions, means function, if you define, they won't execute until you make a call. They get executed, right? If you make a call, then only they get executed. In the same way, Spark on demand, we execute them. Means the data flow means the entire flow executes only when we perform some kind of action. On demand we execute. That's why we say lazy evolution. In memory computation means storage and processing both within the memory level. In memory, within the memory, right? It's fault tolerant power. Spark has got a powerful, right, fault tolerant model. Persistence. Persistence means the executed transformations can be reused. The executed transformations can be reused. Means already the transformations you have done, right? The output, whatever you got, that output you can take and just compute the next things, right? The other things. Yes. Immutability, even if you're modifying anything, the original one remains same. And real-time usage of PySpark, where exactly this in the real-time tasks. real-time usage of PySpark, right? Some applications like within the commercial sector, it is used. Uh, in commercial sector, we use Apache Spark, real-time processing, right? Banks and other financial systems, they are using Spark for retrieving the customer's social profile, right? Social media profile, and analyzing and gaining useful insights, which helps them in taking the right decision. So the extracted information is used, for example, for credit risk assessment, for targeted ads, and for customer segmentation. Spark, see if we say Spark plays an important role in fraud detection and widely used in machine learning tasks. Even in healthcare, right? To analyze the patient's records along with the previous health history, previous is medical reports data, to identify which patient is mostly probable to face the health issues even after being discharged from the clinic, right? Even for the entertainment industry, right? Today, if you see, total industry is moving towards all the industries moving towards this online, right? Like online OTTs, the popular online entertainment platform Netflix uses Apache Spark. It uses Apache Spark for real-time processing. So, and also to like even for personalized online movies or web series, right? It is a so if you can see Spark processes. See the famous entertainment platform Netflix. Netflix uses Apache Spark for real-time processing to personalize these online movies or web series to its customer. So this Spark process nearly 450 billion events per day. 450 billion events per day that are streamed on server side application, right? And even in trade and e-commerce side. So websites like Flipkart, Amazon, all they use Apache Spark for advertising. The other websites also like Alibaba provides offers enhanced customer experience and optimizes the overall performance. And even in the tourism field, right? Apache Spark to provide advices to millions of travelers by comparing hundreds of tourism websites. Okay, fine. I'll come back why Python is used, but before that, okay, you can just check what is the course content we'll be discussing as part of this. So PySpark introduction, what is Apache Spark, why PySpark, need for it Spark, and PySpark features real-time usage, Python, PySpark web applications, Spark sessions, Spark context, RTD, and parallelizing, repartition, coalesce, broadcast variables, accumulators, PySpark RTD computation, operations on an RTD, steps in RTD computations, persistence features, persistence options, and PySpark core computations, grouping segregations, and various actions and transformations, right? Various actions and transformations. So we have got inbuilt actions and inbuilt transformations. So we can apply any of these actions and transformations. PySpark SQL data frame. Making data structured, yes. Case classes, ways to extract case class objects, data frame APIs, data sets, and the RTD's data frame. And PySpark creating data frame, creating empty data frame to pandas, structure types, row class, column class, select, PySpark collect with, we have got many functions with column renamed where, drop, order by group, join, UDF, user defined, map, flat
ये
map,
बोल रहा है रे
fill and fill. Yes, please be in.
आवाज तुम्हारा नहीं आ रहा है रे साहब से
Swetanjali, please be in mute. Okay. Drop duplicates, order by, group by, join, union all, UDF, flat map for each array type, map type, right? Yes. PySpark SQL functions, PySpark aggregate functions, window functions, JSON functions, read, write, and JSON files, various built-in functions. All these are built-in functions, and we will be discussing about all this built-in functionalities of PySpark. PySpark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON transformations and actions, narrow and wide transformations, neuros, handling nulls, joins, window function, writing data back to external sources, right? And deployment modes. What are the various deployment modes? Local mode, cluster mode, and PySpark application stages, drivers, executors, building Spark applications pipelines, deploying Spark applications to cluster and tuning, performance tuning. PySpark streaming concepts, integration with Kafka, and PySpark ML, right? This is what I'll be discussing as part of these codes, right? So the duration is 10 weekends and the fee structure is 8K for this. So in why Python we are preferring rather than Scala. So Python very less coding as compared with other programmings, right? Not even 1/4 coding as compared with other programming languages. Simple syntaxes given by Python looks like normal English statements. Okay, hybrid features. Python has got multi-programming features. Hybrid features nothing but multi-programming features like procedural-oriented, object-oriented, scripting, and modular programming features, right? It has got multi-programming hybrid features. Interactive mode can interact with, we can interact with Python statement by statement, many built-in libraries. 89,000 modules Python has got. And if you check, if you want to compare the speed of other databases, Hadoop and Spark, right? So there was a test conducted. Processing, if processing point of view, you can see Yahoo has taken a table of 100 TB, right? Consisting of 1024 columns, task sorting based on 16 columns. Okay, if I've taken 100 TB of data consisting of this many columns, sorting based on, so Oracle has taken 3.5 days to process it. MySQL has taken 6 days to process. Teradata has taken 4.5 hours. Netija has, see this Teradata for data warehouse purposes. Netija also a specialized database used for data warehouse purpose, has taken 3 hours. Finally, Hadoop has taken 3.4 minutes. So this in days and in hours and days, but Hadoop in minutes. But Spark is 100 times faster than Hadoop, right? Spark is 100 times faster than. So PySpark, okay, it's mainly designed for batch applications. There are two types of applications, batch and online applications, right? Not for Spark, Hadoop and Spark. These are not for online applications. They are for batch applications. Batch applications Online applications means user interactive applications where user gives the input like booking a ticket, movie ticket, a railway ticket, right? A flight ticket, any online transaction you are making, right? User involvement required for online application. For batch application, user non-interactive applications. For example, most of the financial applications are batch applications. For example, if you're generating credit card bill statements for lakhs of customers, for millions of customers, here user involvement nowhere required. Similarly, for mobile bill statements for millions of customers, right? So they are batch applications which are created at the background without any interference of user. Iterative algorithms. PySpark is mainly designed for iterative algorithms. Iterative algorithms. Iterative in the nature means like recursive nature. Most of these algorithms means for machine learning kind. So if any error occurred, again we will be applying the same until the error becomes zero, right? Interactive queries like SQL queries, we work with pure SQL queries, right? And for streaming and streaming applications. So what are the various features you see in PySpark? Very high speed processing as compared with other technologies, right? In-memory computation, which you won't see in most of this. Storage and processing both happening within this memory level, right? Distributed execution. Distributed execution means Spark data objects are divided into multiple partitions. The partitions are distributed across multiple slave machines and are processed parallelly. And multi-language support, it supports multiple languages like Scala, Python, Java, or language, right? Multi-lang, okay, supports advanced analytics, graph algorithms, parallel processing. Persistence feature, this is one of the important feature, right? Persistence feature is one of the important feature. Streaming means, okay, what do you mean by streaming? Streaming means streaming data, we say. What do you mean by streaming data? For example, streaming, what do you mean by streaming? For interactive kills and streaming or streaming data. For example, you downloaded a movie of 2 GB. What is the size? 2 GB. Morning 2 GB only. Afternoon if you see 2 GB. Evening also 2 GB, right? But if you take a file, for example, a webcam, a CCTV, right? Morning, the size was 2 GB. Afternoon, it will become like 4 GB. Evening, like 6 GB, right? Which keeps on generating. The data which keeps on generating. The data which keeps on incrementing. Live streaming data, we say, right? Continuous data flow, yes. Data which keeps on generating, the data which keeps on incrementing, right? Such kind of data we call it as streaming data, live streaming data. I have got tools like Kafka here in Spark. PySpark, see, once again I'm saying Spark is an execution model, right? Using Python language. So mostly used for processing computations, creating data pipelines. Persistence feature means if you have got some 20 step, the 10th step output is used by multiple flows. The 10th step means it is providing output to the different flows. Means second flow, third flow, we no need to start from the first onwards. Directly you can take the 10th one output and you can compute the other things, right? persistence, making that particular data object to be in the RAM, so that it provides output to the other flows. So we'll see more discussion on this persistence. Powerful fault tolerant model. If any slave goes down, if any system goes down, there won't be any data loss. Okay. So RTDs we say resilient distributed data set. RTD full form resilient distributed data set. Spark data objects, we call them as RTDs. Spark data objects are called as RTDs. The RTDs are subdivided into partitions, and those partitions are distributed across multiple RAMs of multiple slave nodes. So in Spark, if you take any data object, it's divided into multiple partitions and distributed across multiple slaves. Here the advantage is bigger data objects can be loaded into RAMs. RTD programming style is data flow. In Spark RTD data flow, right? What do you mean by data flow? It's a sequence collection of pipes. Pipes means RTDs. In a RTD data operation, the operation, so here data flow is sequence collection of pipe. Pipe means any data operation like loading data, transforming data, filtering data, grouping data, merging data, sorting data, right? Pipe. In Spark, data flow is executed sequentially, RTD by RTD, one after the another, with in-memory computing feature and persisting feature. See, in Spark is a data flow language, I'm saying. Observe this diagram, right? Yes. First RTD1, how it is created? Using Spark context, text file. If you are loading a file, RTD1 is created. RTD1 output is taken as input by RTD2. RTD2 output is used by as input to RTD3. RTD3 output is used as input by RTD4. So in this way, think that there are some 20 RTDs. RTD 20 RTDs where they are getting stored. RTD means data object. All these 20 RTDs are not going to get accommodated into the RAM. RAMs, we doesn't have that much of RAM capacity. The first RTD is divided into multiple partitions and loaded across these multiple machines. It computes, the output is taken by the next RTD. RTD1 output is taken as input by RTD2. When RTD2 is ready, see 20 RTDs you cannot fit into a RAM. All RTDs won't be stored in the RAM. When RTD2 is ready, RTD1 partitions will be removed from the RAM. Observe here, RTD2 is ready, RTD1 partitions. When RTD3 is ready, RTD2 partitions will be removed from the RAM. RTD4, RTD3 partitions will be removed. When RTD20, RTD19 gets removed in this way. Finally, once the execution completed, means here what is your observation? If multiple RTDs, all of them cannot be accommodated in the RAM, So whenever the next one is ready, the previous one gets removed, collects the output, collects the output, and the previous one it deletes in this way. Now at the final, once that output is collected, final, this one also got removed from the, this also gets removed. Now what is present within the RAM? Yes. What is present within the RAM means no RTD within the RAM. All the RTDs got loaded, processed, output collected, and they got removed. No RTD within the RAM now. Now you can trigger the next flow. You can trigger the next flow. Then also one by one RTDs. So that's what I was saying here. RTDs in Spark data flow is executed sequentially, RTD by RTD, one after the other, but they cannot execute parallelly. Two RTDs cannot execute. They always execute sequentially, one after the other, because RTD2's output is the input. RTD2 input is the output of RTD2. Okay, RTD by RTD, one after the another. But see in this way, RTD by RTD, one after. But these two RTDs cannot execute in parallel. But if the RTDs has got, RTD1 has got 20 partitions, RTD2 has got 20 partitions. See here, two RTDs can execute, cannot execute in parallel. But if the RTDs, this RTD divided into 20 partitions, assume if it is divided into 20 partitions, these partitions can execute in parallel. Means if you are taking any data object, it is divided into 20 partitions. You think they'll be stored across 20 slaves systems and are processed parallelly. If RTDs have 20 partitions, then these partitions can execute. See here, 1 second. RTD1, 20 partitions. P1, P2, P3, P4. RTD1 output is taken as input by RTD2. These two cannot execute parallelly. But if RTD1 has got 20 partitions, these 20 partitions can execute parallelly. P1 to P20. You need to understand something about persistence, data flows, and persistence in Spark. See this flow, R1, R2, R3. From R3 you got R4, you got R5, you got R6, you got. Observe here, first flow. This is the first flow. R1, R2, R3, R4, R7. Three flows are defined here. First flow, if you take the example of the first flow, right? Yes. If you say R7 dot action, R7 dot action, right? Whenever you perform action on this R7, entire this flow will be executed. Entire first flow gets executed. Until then, it's not executed. That we call it as lazy evolution. Whenever you perform any action on this last RTD, then that entire flow from the first RTD to that particular RTD will be executed. That we call action and lazy evolution, right? That is lazy evoluted. R7 dot action means yes. From R1, R2, R3, R4, R7. Once R1 is ready, these partitions are loaded. Its output is collected by R2. When R2 output is here, once this output is collected, and when R2 is ready, R1 gets removed from the RAM. When R3 is ready by collecting its output, when R3 ready, R2 got removed from the RAM. When R4 ready, R3 removes. When R7 ready, R4 removed. When the total execution finished, R7 also removed. So no RTD is present in the RAM. Second flow also, right? Second flow also, if you observe, right? Second flow also, yes. R1, R2, R3, R5, R8. When this R2 is ready, R1 gets removed from the RAM. When R3 is ready, R2 gets removed. When R5 ready, it's total execution completed. R8 also removed. Now nothing is present in the RAM. You can trigger the next flow. See how this flow, third flow also the same manner, right? When R1, R2, R3, R6, R9. When this R2 is ready, R1 that when R3 is ready, R2 gets removed. When R6 is ready, R3 gets removed. When R7 is ready, this gets removed. When the entire flow is completed, this R7 also removed. Now nothing is present within the RAM, right? But if you observe here, the drawback what we see in all the three flows, first three steps are common, right? These three steps are common. Still, even though they are common, still you are re-executing from the beginning. Okay. Now what happens? The first three, think that if you've got a bigger flow of 40, think that the first 20 steps are same. Means every time you are re-executing from the starting, right? But if 20 steps are same, why can't you use that 20th output and go with the next flow? Means 20 steps decreased, right? So in such case, persist this. Persistence means R3 dot persist, we say. Persist method R3 dot persist. Persisting means making this RTD available in the RAM even though the next RTD is ready. Now if you see, now when you persist R3, now see the flows now. First time the flows will be R1, R2, R3, R4, R7. Yeah, persist means this R3 output is used by 3 flows. See, this R3 output is used by this, and this. So generally, the particular RTD's output used by multiple flows, that RTD you persist. Understand? Here, why I am persisting R3 only? Because its output is used by 3 flows. Yes. So I am persisting. If I persisted it, now see that what is the difference you are observing? When R2 ready, R1 removed from the RAM. When R3 ready, R2 gets removed. When R4 ready, R3 not removed. When R7 ready, R4 removed. When R7 also gets removed. Now, which is present in the RAM? R3. Now, R3 is in the RAM. This is the RAM. Now, what is in the RAM? R3 is in the RAM. Now, just observe second flow. If you want to execute, you will perform action on this last one, R8. R8, you will say. If you see R8 dot collect, you say, or action, you say. R8 dot action, if you say. R8 input is what? From where it should get the input from? R5. R5 input is what? From where R5 input? R3. Now R3 available in the RAM, right? R3 available in the RAM, right? R5 input is R3. R3 available in the RAM, right? To give you this output. So by taking R3 output, R5 and RT, this is the flow. No need to start from the beginning because R3 is available in the RAM to give its output to the other flows. Okay. Now, see the third flow. R3 is in the RAM. So when R5 ready, R3 won't be removed. When R8 ready, R5 gets removed. When the total execution finished, this also gets removed. Now what is in the RAM? R3. Now R3 in the RAM, see the third flow. R7 is the last one. R7 dot collect. One second. Yes. Yes, see the third flow. Whenever you say R7 dot collect,
Hello.
Yes.
Sir, sorry. Sir, class session is started now or when, sir?
Action. Action. Whenever you say action, right, the flow is going to get executed. So actions, we have got many actions I'm going to discuss as part of this course. Like action, like collect is one action, count is one action, take is one action, multiple actions, right? Yes. So whenever you say collect, then the flow is going to get executed from the root. So the same way, only the RTD which is persistent will be available, all the remaining will be one. So here the advantage of persistence is no need to execute from the starting, directly from R3 output you can take. So the flow will be R3, R6, R9. No need to go from the starting. As R3 is available in the RAM, it gives its output to the next one. Yes. Okay. Fine. So now I'm going to discuss about the fault tolerance model in Spark. Now I'm going to discuss about the fault tolerance model in Spark. Fault tolerance model in Spark. So the important feature of Spark is two things, right? The important feature of Spark is two things. So before I go with fault tolerance model, once again, see, have a review of what is two important features of Spark. One is in-memory computation. In-memory computation, where you are not going to see another programming language, other language technologies, right? In-memory computation is one. And persistence feature. Persistence feature. Persistence feature is also one of, and I will come back to this persistence feature. Different types of persistence options are there, but when to persist, how to persist. Now, before that, okay, I'll come back to this persistence. Persistence feature means if you persist any RTD, that RTD always remains within the RAM, and for the it will use its output as input to the other flows. Otherwise, we need to go from the starting. If 5 flows are there, 5 flows, every time you no need to execute from the beginning. If any RTD is persisted whose output is used by many flows, from that RTD onwards, we can start the flow. Case 1. When current RTD machine is down, fault tolerance model in Spark. When current RTD machine is down, means current RTD machine is down means, okay. RTD1 is the RTD1 output is taken as input by RTD2. RTD2 has got P1, P2, P3, three partitions. RTD2 has got three partitions. Think that three partitions. P1 stored in slave 1, system 1 or slave 1, P2 in slave 2 or system 2, and P3 in slave 3 or system 3. Think that this system is down. So RTD1 output is taken by RTD2 as input, and this into three partitions. S1, S2, S3. Suddenly one system is down. See, I'm just making it clear. I'm writing. During the execution, see this? These are fault tolerance. Spark has got a powerful fault tolerant model. During the execution, of the current RTD R2, yes, during the execution of the current RTD R2, if any one partition during the execution of the current RTD R2, okay, if any one of the partition machine is down, assume think this S3 is down, this P3, then how Spark is going to compute this means all the current RTD, then all the current RTD partitions, all the current RTD partitions P1, P2, P3 will be deallocated. See what happens if any one system is down, all the partitions will be deallocated. Deallocated means what? Cleared from the RAM. All the partitions will be cleared from the RAM. Yes. And reloaded into other slaves. Understood, right? So when any system goes down, then again it will deallocate. It is going to be it deallocates all the partitions will be deallocated, cleared from the RAM and reloaded into other slaves by taking the input from the previous RTD. Still this previous RTD available. When RTD ready, computed, until then this RTD1 is not removed. So still RTD1 is ready. Now we can get the output once again from this RTD1. And again, I will store that partitions P1, P2 in 3 different slaves other than this, right? Other than the one which is down. It can make use of any other slaves, right? Understood this case one? Hello?
Sir,
Yes.
so we said our PySpark will reload into other slaves, right? So in this
Yes.
context, other slaves are nothing but S1 and S2, only two, or will it take S4 as well?
You have got some multiple slaves are available. S1, S2, S4, S5, S7, S8. Except S3, any other slaves it can make use.
Oh, okay, got it.
It can make use of S1, S2, but except the one which is down, right?
Sure. Okay, cool.
In this case, all P1, P2, P3 removed from the memory, and it will take from other slave instance, right, sir?
So here, first R1 output collected by RTD2. It
Yes.
should be stored within the memory RAM.
Yes.
So what happens? It is stored into the 3 partitions stored in 3 machines, 3
Yes.
slave machines in their RAMs. Suddenly one machine down. So what happens? It is stored in all this. Once again, all this will be deallocated from the RAMs.
Okay, sir.
From S1, S2, S3. S3 anyhow it is down. S1, S2 also it will be deallocated. It will be removed. Again, it collects this. Why? Because this P3 is lost, right?
Yes, sir.
P3 is lost. So P3 is lost means some data is lost means. So again, it is going to collect that from RTD1. Again, it is going to store this 3 partitions in 3 different slaves. Other than the here, I'm writing a note here. 3 partitions.
In this case, it's not going to collect from any other slaves, right, sir? It's a collect from the RTD1.
From RTD1 only, it is going to take RTD1 output will be taken as input by RTD2. So here RTD1 partitions are stored, right? From that output is collected by this and stored across 3 slaves. 3 partitions are stored in 3 different machines. 3 different machines. Excluding the machine which is down. Excluding the machine which is down, right?
Sir, in this case, for example, replication factor may be either 2. This whatever the P1, P2, P3 will be stored in other missions also, right? In that case, all maybe example consider S till S6. All it going to deallocate and get the data from RDD1 again.
There is no concept of replication in Spark.
Sorry, sir.
Hello. The 3 partitions are stored in 3 different machines, excluding the machine which is down. So previously in Hadoop, the replication, but here in Spark, there is no replication.
Oh, okay. Okay, sir. Got it.
So 3 partitions are stored in 3 different machines, excluding the machine which is down. Understood this first case, right? When current RTD machine is down, when the current RTD machine is down, means from RTD1 to RTD2, current RTD is RTD2. So I'm saying this as current, just is previous.
Sir, it can be S1, S2 and S4, right? 3 partitions means it will be
3 partitions.
different partitions, right? So S1, S2, S4 we can consider, right?
When S3 is down,
Yes.
when S3 is down, it will be stored across some other slave other than S3. Here S3 is down, I am saying. In that case, you can
Yes.
go with any other slave other than S3. So 3 partitions are stored in 3 different machines, excluding the machine which is down.
Down.
This is the previous one. This is the current RTD. Right. So here you are asking how to make in by default. Okay, we can control the parallel processing in Spark while loading the file, right? While loading the file, for example, if you're loading a file, the file path, beside the file path, if you say 4 means 4 partitions, if you say 8 means 8 partitions, if means 20 means 20 partitions. You give the file path, right? Where the file is available. Using Spark context. So there are 3 ways to create an RTD, right? Using Spark context, if you are loading a text file. Using Spark context, if you are loading a text file. File path. Into how many partitions? 20. 20 partitions, the file path, big data file. Using Spark, then RTD1 is created. Using Spark context, using Spark context dot text file path. Okay. 20. Partitions you will be getting. RTD1 is created. Okay. Okay, if replication concept is not applicable, then we will lose the data once the slave is down. Now the slave is down, right? Now how it is recomputing? Now if the slave is down. See why the replications observe here, while replications, because P1, P2, P3, if you are replicating for 3 times or 4 times replicating, 4 times replicating means 4 times if you are duplicating like Hadoop. P1 for 4 times, P2 for 4 times, P3 for 4 times. You are not storing in disk, you are storing in RAM, right? To accommodate those many partitions, duplicate partitions, you need to have enough RAM capacity, right? So in the case of Hadoop, okay, but here RAM in memory space, right? Replicating for those many times cannot be accommodated by the RAMs. So in such case, what you do, if any machine is down current, then deallocates cleared from the RAM and reloaded into other slaves by taking the input from the previous RTD. Case 1, have you understood everyone? Any queries in this?
Sir, here, for example, before down, actually, any partition, if you take the input from RDD1 to the RDD2, but previously RDD1 data will be something will be lost from the RAM, right? So in case of partition is down, how come it will go to RDD1 for data?
So here until RTD2, so until RTD2 computed, RTD1 partitions will be available into RAM. When totally RTD2 is ready, computed, then RTD1 gets removed.
Okay.
Okay. Now see this. I'm going to discuss like 3-4 cases here. You'll be getting all those. When RTD3 is computing, RTD1 data won't be available. When RTD2, RTD3, then RTD1 won't be available. Now see this case 2. Observe this case 2. If previous RTD RTD machine is down, if previous RTD machine is down, means R1 to R2 to R3. This is previous. This is current. Now you need to answer me. During the execution of R3, during the execution of R3, during execution of R3, while taking the input, during the execution of R3, while taking the input from R2, suddenly if R2 failed, R3 is taking input from R2 while taking the input from R2. Suddenly if R2 failed, R3 is taking the input from R2. R2 output is input to R3, right? R3 is taking the input from R2. Suddenly R2 machine down. R2 is failed. Then R3 won't get the input, right? If suddenly R2 failed, can I reload R2 again? Suddenly R2 failed. Can I reload R2 by taking the input from R1?
Yes, sir.
R2 can't be reloaded or reinitiated into other machines because R2 input is R1. Which is not available, right? Which is not available in RAM. When R2 ready totally, R1 got removed. Now R2 output need to be collected by R3. Now suddenly R2 down. Which is not available in RAM. So what is the only possibility? So the process should start from beginning or from the persisted RTD. So the process should start from the beginning or understood, right? Here R3, R3 wants to collect the input from where R2. Okay, during this process, any one of the R2 machine is down. But to recompute R2, just like the case one, R2 partitions, I want to reload and I want to recreate R2. In such case, R2's input is R1. R1 is not available. It already got removed from the RAM. So R2 cannot get the input. R2 cannot get the input. So this R2 can't be reconstructed. If R2 is not reconstructed, R3 cannot get the input. So again, the flow will start from the beginning. Again, comes from the beginning.
Hello, sir. I am audible.
Yes, you are audible to me.
Okay. Can you please tell me how to do partitioning?
So generally, in while loading the file, beside the file, you will give that how many partitions you want. 10 partitions or 20 partitions. Where your file path is available. Beside that, just I was talking before, right? Give comma and give that number of partitions you want. Those many partitions you are going to get.
Max 20 partition we can create, right?
Pardon?
Max 20 partition we can create, right?
Not max 20. Example I have given.
Okay.
Example I have given 20 partitions. Any number of partitions can be created.
Okay.
So here, so the process should start from the beginning or from the persisted RTD. Here, understood, right, everyone? This case 2.
Sir, one doubt, sir. Sorry, in the previous example which someone asked, no, number of partitions in the sense number of slaves available, number of CPUs available, right, sir?
No. See here, for example, I got 40 slaves, 40 systems, you think.
Okay, 40 systems.
40 systems available. I have got a data object.
Okay.
Data object. The data object divided into 20 partitions.
Okay.
Assume 20 partitions.
Yes.
20 partitions are going to be distributed across 20 systems, 20 slaves, right?
Yes, sir.
But available 40 systems are there.
Yes, correct.
40, 20 systems, it is happening. Remaining 20 are free.
Yeah, correct.
Means here, can you say the number of partitions equal to number of slaves? No, right?
No, sir.
So slaves, you will maintain some cluster with a number of slaves.
Okay.
So that your data is going to get distributed across. Means why your data is distributing means if data is distributed across multiple systems, multiple slaves, right? You're going to have parallel processing.
Yes.
Multiple systems are running parallelly on the same job, right?
Yeah.
The same file. If data is stored across multiple slaves, only parallel processing can happen. Each slave processing some lakhs of records.
Yes.
So here the number of partitions stored across multiple machines, number of slaves, that is systems, is not equal to number of partitions. Right?
Yes.
Got clarity in this?
Yeah, thanks.
So here when R2 is down, R1 is not available, right? So in such case, again, you start R1, R2, R3 from the beginning. The flow need to start from the beginning. There is no other chance. Next. If a persisted RTD machine is down, if a persisted means, okay, assume this flow, R1 output is taken by R2, R2 output is taken by R3, R3 is persisted. What do you mean by persisted means? Persistence means making the RTD available in the RAM even though next RTD is ready. If this is only down, assume this is down. Persisted RTD, R3 is persisted in particular machine, that machine only down. R2 and R1 are not available, right? To recompute R3, R1, R2 are not available, right? Understanding? Hello? Here R3 to recompute, or if you want to load, reload, right? R2 is not available, R1 also not available.
R4 is already available. Then 5 you have make R3 as persisted.
So here R1, R2, R3. R4 need to get R4 need to get the input from R3 during that getting process. During that, while getting that process, right? R3 is down. Observe here. During computation of R4, during the computation of R4, and while taking input during the computation of R4 while taking the input from R3, if R3 is down, then here One second. While taking the input from R3, if R3 is down, then the flow will be re-executed. Here, one thing you need to understand, the flow will be re-executed automatically from the beginning. Till R3. The flow will be re-executed automatically from the beginning till R3. Without performing. So here the flow will be re-executed automatically from the beginning, means from R1 till R3 without performing action. And R3 will be and R3 will be re-persisted. R3 will be re-persisted. Okay, during the computation of R4, while taking input from R3, if R3 is down, the flow will be re-executed automatically from the beginning till R3 without performing action, and R3 will be re-persisted. Understood? So here automatically the flow will start from the beginning till R3 and R3 will be re-persisted. Once R3 is done, now R4 can be completed. Excuse me. Now observe this case 4. While executing R5, for example, R1, R2, R3, R4, R5. R3 is persisted here. While executing R5, while executing R5, while executing R5, while taking input from R4, If R4 failed, no, try to answer. Try to comment on this. Yes, I got some answers, right? But you can
Take
just,
the input from R3.
yes, takes the input from R3, right? R3 is available in the RAM. R1, R2 not available, but R3 persisted, right? If R4 is failed, then the input is taken from R3. Then the input is taken from R3, which is persisted. The input is taken from R3, which is persistent, is available in RAM. While taking input from R4, if R4 failed, then input is taken from R3, which is persisted and is available in RAM. And R4 partitions will be reloaded and provides input to R5.
So in this case, it going to re-execute R4, then output is going to give to R5. Right?
Yes, yes.
Yeah.
Because R4 to recompute, R3 available, right? That's the advantage. R3 is available because R3 is persisted.
Yes.
Means persistence means making the RTD available in the RAM. If two RTDs are persisted, now in such case, now if two RTDs are persisted, R1, R2, R3, R4, R5, R6, R7. R1, R2, R3, R4, R5, R6, R7. If two RTDs are persisted, R3 is persisted, R6 also persisted. In that, the first one, right? In the first case. If R7 is down, then
Take the input from R6.
yeah, R6 is available, right?
Yeah.
As R6 is available, R7 takes input from R6 and recomputes. In Hadoop, the file is divided. In Hadoop, the file is divided, right? That file is nothing but your RTD in Spark. Means the same file is loaded using Spark context. We call it as an RTD.
But in Hadoop, we store it in secondary storage, right? But in Spark, we store it in primary storage.
Using Spark context.sc.text file, if you are loading a file, the resultant is an RTD. See here, using the Spark context.text file, if you are loading a file, the result whatever you get from this is a RTD.
Once RTD is successfully executes, it will store it into the hard disk one, secondary storage.
There is nothing to be computed within this disk level, right? In Spark totally in memory computation.
Yes, after that processing, the table is ready, RTD is ready.
If you want to store it, if you want to store the result, you can store it back into Hadoop HDFS. Yes, save as text file is available, right? If you want to, if after processing the processed results, if you want to store, you can store it. No. Everything happens within the RAM only, right? RTD1 loads into the RAM. When RTD2 is ready and RTD1 gets removed. When RTD3 is ready, RTD2 gets removed. RTD4 ready, RTD3 removes. Nothing will be there in the RAM once the total execution finished. But if you persist R3, only R3 will be available. Okay. So practically, I'll be showing you these things, right? How to create an RTD. There are 3 different ways for creating an RTD. I'll just take separately 3 different ways to create an RTD. Okay. Second one, see the second one. In the same flow, if R6 is down, R7 down means okay. If R6 down,
Takes the input from R3.
yes, what is that?
R3.
Flow re-executes from
R3.
R3 to R6. The flow re-executed from R3 to R6, from R3 to R6 automatically, and R6 will be re-persisted. Yeah, any query?
No, sir.
So flow executes from R3 to R6 and R6 will be repersisted. That's it. Okay. If R3 machine is down, hmm, hmm.
R1 and
Then
R2 is not available, right?
flow will start from the beginning.
F6
R-
is still persisted, right? So it starts from F6, R6, sorry.
If R3 is down means, okay, if R3 machine is down, then there is no R4 and R5 and R6.
From the scratch, again we have to load.
So if R3 machine is down, then the flow R6 cannot give any kind of input to R3, right?
Yes.
Even though if it is persisted, if R6 is persisted, it cannot give its input, right? It only takes that input from R3. R6 will be getting the R3 output as input, right? But R6 is nothing to do to R3, right? R3 will provide its output to R6, but R6, no, you cannot go in the reverse. So if R3 machine is down, then the flow will be re-executed from
Beginning
R1 to
R1.
R3.
But sir, R6 would be persisted at that time also.
Or, pardon?
R6, when R3 will be down, then at that time R6 will be there.
Yes, it can be there.
So when we will start from R1, then again we need to make R6.
No need.
Till R5 we can create, and then we can reuse that R6 for creating R7.
R7 you can create directly from R6. If R3 there, R4, R5 can be created.
So it means like till R5 we need to create, and after that we need to stop.
So here, if your flow is okay, R3, if R3 machine is down, then the flow will be re-executed from R1 to R3 automatically, and R3 will be repersisted, and R3 will be repersisted. So if you want to execute the flow from R1 to R5, now R3 available, right? Repersisted. Now R3, R4, R5, these three steps enough to execute R5 to get. If you want R5 output, the flow of R3, R4, R5. If you want R7 output, R6, R7 is the flow. Already R6 available.
Got it, sir.
Okay. Fine. Okay, now see this, understood that this 5, right? Case 5, 1, 2, 3, 4, 5 cases. In the case 1, if the current RTD machine is down, means current RTD machine is down, the previous RTD is still the data available, You will collect the data and again you will reinitiate the same thing in 3 different steps. Importance of persistence. Now see this importance of persistence. Example, R1, R2, R90, 90 RTDs are there. Case 1, observe this case 1 during computation. 90 RTDs where they are stored
In the RAM.
System.
initially. The RTDs are just declared, they are not stored anywhere. One by one RTDs will be loaded into RAM. All the 90 RTDs cannot fit, cannot accommodate it into the RAM. During computation of R90. Try to say this while taking the input from R90 or 89. While taking the input from R90, if R90 is down, where I need to start the flow from?
From the beginning, flow execution starts from the R1.
From R1 to R89.
No.
sir, but R89 is not available in the RAM, right?
See one thing, see that case one. Observe this case one.
Yes, sir. Similar to case one, it is.
Current RTD is down. Previous RTD takes the output. See, during the execution of during the current RTD machine is done. Our current RTD is R90. Previous RTD is what? R89. If any one of the partition is down, then all the partitions will be deallocated from R90 and reloads into other slaves by taking the input from R89.
Okay.
R89 is previous, R90 is current. If R90 down, the previous available, still it takes that and recomputes this R90. Understood, right? Here also the same thing.
Yes, sir.
During the computation of R90, while taking the input from, if R90 is down, it takes the input from R89 and R90 is loaded into other machines and computed. Now observe this case 2, right? Based on your understanding, case 2.
Sir, only after the completed execution of R90, then only R89 will be
Removed.
removed. Okay.
During computation of R90, during computation of R90, while taking input from R89, if R89 down,
Execute from R88 to R90.
It will execute it from starting.
yes, if R89 is down, everyone try to answer, right? If R89 is down, then here, can we recompute R89?
No, sir.
No, because
R87 is not available. 88 is not available.
so yes, R89 cannot be reloaded, because R88 is not available. R88 is not available. Then the flow will start from the beginning. Understood, right? During the computation of R90, while taking input from R89, if R89 is down, yeah, R89 cannot be reloaded because R88 is not available. Then the flow will start from the beginning, that is from R1. So it is re-executing from R1. Okay, it started re-executing from R1, R2, R3, R4, R5. Again, it is re-executing. Okay, here, while re-executing again, it came up to R86. Observe here, while re-executing, again, while executing all 6. If R85 is down, Okay, from R90 failed again, it is re-executing. Again, it came one by one by up to R86. It came while executing R86. If R while taking input, R85 is down. The flow starts from
Start.
the flow will start, that is from R1, from beginning. So in the same case for also same, right? So again, while it is re-executing at any one point again, okay, same, so case for also, and copy pasting. Yes, while re-executing again, while executing, for example, R82, you say, if R81 is down,
Start from beginning.
then the flow again starts from the beginning, that is from R1, right?
Yeah.
Then in such case, what you can do? Here, if R80 is persisted, if R80 is persisted, assume here if R80 is persisted,
Good from start. Directly from R8 we can start.
then no need to execute from the beginning, right?
Yeah.
The flow will be started from R80. Understood, right? But here also there is a problem. Here, if R8 is persisted, the
If R80 is down, then it cannot get the inputs from R1.
yes. So here a problem, right? When R80 will be persisted after 79 RTDs, 88 or when a 79 RTDs computation finished, then R80 is going to be persisted. Directly R80 will be one persisted first, right? First R1, R2, R3, R4, R5. When R80 turn will come, then it will be persisted. Right? After R75, after R76, R88, R90, R80 comes, then it will be persisted. Until then, it won't be persisted. When a RTD will be persisted, so here that is given by the developer only, right? Which one RTD, which one to persist, depending upon your business logic, which one you need to be, whose output is commonly used by multiple flows. The problem is, okay, you have started the flow. Though you have started the flow. R1 finished, R2 finished, R3 finished, R4. Still R80 is not completed. R50 finished, R60, R70. Again, here the problem is while computing R75. If R74 down, even though R80, if you are making that as persist, while computing R75, if R84 is down,
Need to start
flow starts from
beginning.
So here one more thing. So here, what is your observation here? What is your observation here? Every time R80, even though R80, even though if R50, if you are persisting, R50 you persisting means from R50 you will start, means 50 steps decreased from R50 to R75. Okay, you can again reveal, but instead of going from the starting, right? But whenever you persist R50 also, whenever at R40 the machine is down, then again goes from 40 steps. So which is the, so what is the best way? So the best way is
persisting the previous RDD. And once the usage is completed, we can unpersist it.
so the best way is you persist for every 25 RTDs. The best way is persist for every 25 RTDs. 25th RTD you persist, 50th RTD you persist, 75th RTD is persist. 25, 50 and 75. So it R80 down, for R85 down means go from R75, it's persistent. Somewhere between 50 to 75 anything is down, you recompute from R50. Between 25 to 50 anything is down, recompute from 25. And between 1 to 25 anything is down, compute from 1. Understood? The best way is you persist for every 25 RTDs. Or if you have got RAM memory, if you have got good RAM memory, if the memory is good, every 10 RTDs, memory is good, then persist for every 10 RTDs. That is R10 you persist, R20 you persist, R30 you persist. So the best way is, if the memory is good, if you have got good memory, means a lot of memory is available. If the memory is good, then persist for every 10 RTDs. So once the flow is executed, the action is completed, then you can unpersist it, and you can unpersist all the RTDs. Once the flow execution action is complete, and you can unpersist all the RTDs. How you can unpersist means R10 dot unpersist. R20 dot unpersist. R30 dot unpersist. In this way. Unpersisting happens immediately, right? Unpersisting happens immediately on demand. But persisting won't happen immediately. But persisting won't happen immediately. What is this indicates? Unpersisting happens immediately means if we say R30 dot unpersistent, immediately it will be removed from the RAM. R20 dot unpersistent means immediately it gets removed from the RAM. But persisting won't happen immediately. When R80 it is going to be loaded into RAM first time, then only it will be persisted. But whenever now currently R15 is computing, R16, R15, R16 is getting computed. Whenever that R80 dot persist if we give, once R80 when first time it is going to get loaded into RAM, at that time only it will be persisted. But unpersisting happens immediately on demand, but persisting won't happen immediately. Persistence of an RTD happens only when first time the RTD is loaded into RAM, right? Yes. Persistence of an RTD happens only when first time the RTD is loaded into RAM. Understood, right? Any queries in this? So fault tolerance model. Spark has got a powerful fault tolerant model. 5 cases I discussed and the importance of so whenever you perform some action, then only the RTDs will be executed from the root. On RTD, two types of things you can perform. One is transformation, one is action. Transformation, filter transformation, aggregation, grouping, these kind of transformations. The result, whatever you get, is also a RTD. But action, collect, count, take, there are some actions, right? It returns Python object. Transformations on an RTD returns a RTD only. Okay. Next is persistence options. Persistence options of a RTD. Persistence options of a RTD. Where you can persist the RTD? Where are the various, right? Memory only. Memory underscore SCR underscore only. You can Memory only, memory CL, memory underscore SCR means serialized only, serialized form. Disk only. Disk underscore SCR only. Yes. Memory only, memory underscore SCR only, disk only, disk underscore SCR, memory and disk. So these are the persistence options. Means sometimes, for example, memory is full with other RTDs are executing in the memory, but the current RTD is unable to fit into that memory. In such case, you can persist that RTD in the disk, or you can go for serialized form where it occupies very less space. Okay, disk memory and disk. If you give this memory and disk option, right, so if memory available, it will persist in the memory, otherwise it will go for disk option. But here if you give memory only, if memory is not available, it is going to be failed. Memory in serialized form, it is going to occupy very less space. Yes, disk only means if it is too big and it is unable to fit into that memory, even though the RAM becomes free also, even if the RAM becomes free also, if it is unable to fit means go for disk only option, right? So this we have got a lot of discussion on this. So in the tomorrow session, I'll be just discussing on this various persistence options, memory underscore only, memory SCR, disk only, disk and SCR only. And in the tomorrow session, just I'll be demonstrating about the software also, right? So tomorrow I'll be just completing the other things of this this Spark architecture and this fault on this various persistence options, different ways of creating RTDs. Fine. So I'll just demonstrate about the softwares. I'll be forwarding to your drives. So
Sir, from what the class starts at what time? Sir, either 2 or 3, sir. Because I got 2 different emails.
Yes. So yes, one second. So
Sir, and
here,
serial option not explained, right, sir? Tomorrow you're
yes,
going.
yeah. Tomorrow I'll be just going to, and tomorrow the class timing it will be at 3 p.m. Tomorrow we'll continue this at 3 p.m. right? Yes. And still okay, 3 p.m. tomorrow, but one second. Tomorrow you will be getting the link, right? Tomorrow the new link you will be getting. So the still, if anyone not registered, right? If you're not registered, you need to register tomorrow by paying the fees, everybody, and the same link you will be going to continue up to the end of the course. So check your mail IDs. A new link you will be getting for tomorrow's session. So the payment details and the procedure details you can check. Yeah, tomorrow you will be created a WhatsApp link will be created. Tomorrow software will be provided.
Before the session starts, you're going to create the WhatsApp, right, sir?
So at the end of the session, a link I'll be posting in your chat panel. Everybody can click it and get added into that WhatsApp group.
Yeah, okay.
Right? Okay, one second, give me a second. Yes. queries? Yes, some queries asked, right? In RTD1, if P1, P2, P3, only P3 is down, then why can't we reload only that particular partition R3? See, if why can't we reload that particular partition means when you want to take that data from the previous RTD, you cannot take only P3 partition. When you want to recollect that output from the previous RTD, you cannot take only that particular partition. If you want, you can take the entire RTD output, but only P3 output you cannot collect, right? But you will collect that and you will be storing it in different partitions.
And sir, one more question, that in previous example, there were, for example, 100 RTDs are there. And for every 25 RTDs, we need to make it persistent. So instead of doing that, can we do every previous RTD persistent and do unpersistent after the usage?
So you will persist and unpersist. Okay, for example, R24, you persist immediately after that R24, you will unpersist it.
Yes,
but
sir.
While our computing R30, R24 will be available or not available?
If required, then we can keep it, otherwise.
No. As per your logic, right? R30, when I am computing, R24 is available or not available?
24 is not available.
Not available means you are not going to get what
But for
advantage?
R30, we need R29.
Yes, R29, but for example, suddenly R27 down.
Okay.
Then R24 is also not available, right? Again, it should come from the starting. So what advantage you will get by persisting and persisting this? Either you need to make it available that permanently, means you want to, until the entire flow completes, you need to persist it.
But R27 also we will persist, right?
No, R27 suddenly down. R26 not available, at least
After
R24.
persistence, it is down. So we cannot go back. Okay.
R27 is not a persisted RTD. You are saying R24 you persisted immediately after that R24 is completed, you want to unpersist. No, there is no use of persisting then. Persisting means making that output of that particular RTD available until the total execution completes. So that if any RTD down, immediately this RTD will be there in the RAM, right? It will give its out. No need to go from the starting. If you are storing very big flow, if you are going right R1 to R60, if you are persisting R40 means suddenly if R55 down, again you can come from R40. If R50 down, again you will come from R40. R58 down, again you can come from R40. If you are persisting it.
Kind of
But
rollback.
there the problem is, if R38 computation means again you need to come from R1 to R38. So that's why I said for every 25 means it will be better, right?
Okay, sir.
Okay.
Thank you.
Fine. So here, if you see in the chart panel, right? So you can see that entire, yes, Python basics I'll be discussing, right, before I go with the practical part. So tomorrow I'll be just demonstrating, if possible tomorrow I can give you the basics of Python basics. So here you can see the chart panel, right? They have given that the payment process and procedure. It's a 10 weekends batch, the contact details of the online team and the payment procedure, and you are supposed to send the screenshot to them. And tomorrow the link, whatever we are getting, you need to follow up to the end of the course, right? The same link will be followed at the same timing, 3 p.m. will be followed, right? Yes. And
with and without recording, same fees 8,000.
pardon?
With and without recording, fees same.
No, everything there is not like that. It's a common fees 8,000 to all. Without recording, you are asking how much?
Yeah.
Yeah, you can just talk to these numbers, right? You have got this contact details of that. You can take the snap of it. You can talk to them related to that fees.
Oh.
Okay, fine. So I'll stop here and we'll continue tomorrow, right? More discussion on this. Fine. Still any more queries, right? Anyone?
No,
Yes.
sir, all clear.
Okay. So tomorrow I said all the things you'll be getting. I'll also be forwarding the notes to you. WhatsApp group, software, all this once you got enrolled, right? Yes, fine. So I'm stopping here. We'll continue tomorrow. 3 p.m. 3 p.m. tomorrow.